Okay. I have posted on CCLE. I gotta log in. I've posted it last year's midterm exam. Okay, and this is intended so you guys can practice. All right, get a feel for what you might be able to expect next week. Okay, so next Friday will be the our midterm, and I'll double check with the scheduling office. But I think this room, I don't think there's a class after us on Fridays. Okay, so if you want to have like a quiet environment, you can come here with your laptop and work on the midterm, right? So because your own apartment or dorm might not be the best place to take an exam or something. So so if you want a quiet place, you can come here. It'll be quiet. So that's what we have. But anyway, I've posted this, okay? And so these were the instructions that they got last year, all right? And you can see the questions. And this is how I plan on doing it, okay? It's going to look very similar, and I give kind of some instructions, and in this case we were looking at consumer price index for apples, bananas, and oranges. Okay, so this is from the Bureau of Labor Statistics. Okay, so you can go there, and there's lots of data. Okay, and so here I just took some consumer price index values. Okay, and in particular, I was looking at the AP I think data 3 food, right? I think so. Okay, so this is what I downloaded, and it's just a text file, all right? And you'd read this in, and this is like some item. I think it's like flour, okay? And in 1980 January it was 20 cents, and then in 1996 it went up to 26 cents, and then if you were to try to buy the stuff in 2019 September, it's around 45 cents. Okay, so I think it's like a pound of flour. I think that's what this item is. I'm not sure. Okay, there's kind of a list of what these series represents. Yeah, okay, so the very first one is flour, white, all-purpose per pound. Okay, U.S. city average price per pound for flour. So if you were to buy a pound of flour, so you have to buy like a 10-pound bag of flour at the store or something, and according to this, if you bought a 10-pound bag of flour in 1980, it would cost you $2, and today it would cost you around $4.50. Okay, so anyway, you would read that in, and the questions were all about apples, bananas, and oranges, and I just asked things like, make this plot here, okay? And it kind of showed what the resulting plot I wanted to look like, where here's the cost of apples going up, and here's the cost of oranges. What do you see about oranges? So this was from the year 2000 to 2019, I guess, early 2019. What do we know? Oranges have very seasonal things, right? So in some parts of the year, oranges are very expensive, and other parts of the year, oranges are very cheap. Okay, bananas, not much seasonality. Bananas pretty much cost the same throughout the year. Okay, so bananas are fairly stable. Cost of oranges very seasonal. Okay, and then apples. The seasonality is not quite explained, right? So average annual price. This is the average price over the year, and we see something like this. Okay, so anyway, I just have you ask all of these kinds of questions. And that was it, okay? And you had 2 hours to do this, which I think is a reasonable amount of time to work through this. But if you didn't study and if you didn't prepare, it's hard to pull this off in 2 hours. So, okay, so I know we come here and we watch me work through these notebooks, but truly, I think the best way to learn is to practice and do things on your own, okay? And so I strongly encourage you to do those data camp projects. And then, when you feel ready, you should attempt the midterm exam from last year yourself. See if you can kind of complete the thing within 2 hours, okay? Put yourself in kind of a test-like environment. And, you have access to the internet, so you can look up. You can always type Google, how do I make a plot? How do I do this? How do I do that in Python? And that's allowed, okay? You're just not allowed to talk to each other. That's the only rule. You're not allowed to talk to each other. But you can go on Google and look up stuff online. That's totally fine. But you don't want to have to be looking up everything, and you get 2 hours to do it. Okay. Any questions on this? So I think there's I downloaded the files from May 2019. So I guess it's not even last year. It's like last academic year, but still this year, right? Okay, so 6 months ago, I downloaded the thing. So if you wanted your pictures to match, pretty much exactly mine, you can use these files, or you can download the latest files. Okay, so that's that. Here's and then the midterm template. And again, just do some practice, get some practice in. Okay, so there's a considerable amount of doing some visualization stuff, and so today I wanted to cover matplotlib. This is kind of our, one of the most commonly used packages as far as producing plots, okay? So I have to say, I think R is more capable at creating plots, okay? You have base graphics, and then you have ggplot, and between those two and all of the other packages that you can install and stuff, I think R is really good at plotting. That said, matplotlib is certainly functional, and we can do quite a bit with it. It's based off of MATLAB's plotting abilities and stuff, and so if you ever used MATLAB, there's similarities there, but probably very few of you have used MATLAB on a regular basis. Okay, anyway, I'm going to just import NumPy. I'm going to import matplotlib pyplot, okay? So that's matplotlib.pyplot, and the common thing is as PLT. Okay, so this notebook should be on my GitHub. You should be able to download and follow along if you wanted to. Okay, and so if you wanted to plot something, okay, I'm just making up some numbers here. All right, so what does np.linspace do? Here I got np linspace 0, np pi times 2, 500. What am I doing? I'm just creating a vector of length 500 going from 0 to 2 pi, right? And then I'm going to ask NumPy to calculate the sine of x. And so now I have a vector for x, a vector for y. All right, and let me just I'm going to just break this up first. If I just do plt.plot xy, it plots this, okay? And then you can add stuff like the titles, okay? plt.title, sine of x. You can change the x limits. So by default, the x limits go a little bit lower and a little bit higher. But I can say the x limits should be 0 to 2 pi. And then you can call show, and it will plot the thing. So I've added a title, sine of x. I've changed the limit so it goes from 0 to 2 pi. And then I called show. All right, here I'm just doing some random integers. 0, 5, 1, random integer 0, 10. We're going to ask for 5 of these things. And the numbers that I generated are 1, 2, 3, 4. And the random numbers that I have are 5, 4, 1, 2, and 1. Okay, if you do this, you're probably going to get different random integers. Okay, so by default, plt.plot, pyplot connects these coordinates with a line. Okay, so it starts off at 0, 4, and then it goes to 1, 5, and it connects them with a line. If you don't want them connected with a line, and if you wanted them plotted as dots, you would call plt.scatter. And then when you call show, it looks like that. All right. All right, and of course, if you forget any of this stuff, you just say scatterplot Python. Okay. Oops, not Python. Okay. And then probably, let's see, matplotlib pyplot scatter. Okay. Oh, and look at this. Our Python data science handbook also shows up right here. Okay. So here we got, this is the documentation for matplotlib, and you have all of this, and then and here's stuff you'll find a bunch of stuff online as well. Okay. I guess I should point out that this is the website for matplotlib, and you can always read the documentation. A lot of times you can go to kind of click examples here, and you can kind of see like what are some of the things that other people have produced, right? So these are kind of your typical things that you might want to make, right? So, oh, I want to make a bar chart, okay? And this will be kind of the commands that we do. So you're going to do axes. So here we define a set of axes, and then we're going to call bar, set ticks, invert y-axis, and stuff like that, okay? Bar H for horizontal bar plot and things like that. So you can often look up in the examples something that you might want to make and then adapt the code accordingly, right? So a lot of this is being able to read the documentation and see what needs to be done. And so you can always look up whatever function you need. Okay. All right. To make a histogram, I'm going to just generate some 10,000 numbers from the random normal distribution. Rand n will give us random normal values. I want 10,000 of these things. I'm using NumPy's random capability, and I'm going to say make a histogram, plt.histogram of z, and we're going to say I want 30 bins. Okay. And there's your histogram. Now you can change this. You can say I want 300 bins, and we're going to get something a lot more jagged, right? Or you can change this down and I say I want only 10 bins. Okay, it's a lot more something, right? So you choose whatever you want to do. 30 bins seems reasonable. You can plot a bunch of these things, okay? So here I've got x is going to be 0 to 2 pi, linear spaced thing, and I'm going to calculate y, z, and w. So I'm going to calculate the sine, the tangent, and the cosine. So this is all done in NumPy, and this will just give me kind of these arrays with 500 values in them. All right, and here I'm going to just keep calling plot x and y in blue, and plot x and z in red. All right. So y is sine of x, and z is the tangent of x, and it plots both of them on the same thing. Okay. The only trouble is what's going on with the tangent. The tangent technically runs off to positive infinity and negative infinity. Now, because of our thing, it doesn't actually go to infinity, but it goes to 300 and negative 300. And so we completely lose the variation that appears in sign, right? So the sign bounces between -1 and 1, and we lose that, okay? So maybe a little bit better would be to just show sine and cosine, and here I'm going to just say plot x and y in blue, x and w in orange, and we have that. So there's sine and there's cosine, and again, you can adjust a lot of these things, right? You can always just say matplotlib set x-axis limits, right? X-axis range or something, right? So you do this, and you go, oh, how do I do this? Okay, we're going to do pyplot, and we're going to do xlim. Okay, so that's what we want. So you can, so you're going to do, pyplot.xlim, and we're going to go from 0 to 2 times pi. Oops. Okay, and there you go. So pretty much you just have to know how to do a search on Google, and generally the help functions or the documentation will show up. Matplotlib supports subplots, okay? And so what you do here is you use this function subplot, all right? And the arguments are number of rows, number of columns, and the plot that you want to draw, okay? And this uses MATLAB, so it's not zero index. The first one starts off as number 1. So here I'm going to do subplot 221, and so it's going to be, we've got a grid of 2 by 2, and we're going to draw something in plot 1, which will be the upper left, and then, so that will be sine of x, and then I'm going to do 2 to up 2, which will say, in the same grid that's 2 by 2, go in the upper right, okay? 2, 2, 3, and 2, 2, 4, all right? So all of these things I'm just continually call plot, title, subplot tells Matplotlib which side I want to draw on, and does accordingly. So the top left, it will draw x, which is x versus y. Over here in the top right, it draws x versus w, which is the cosine. Here in this one, we have x and z, which is the tangent. And then lastly, we have, I did both xy and xw in red and blue, and that plots the sine and cosine. Okay. So that's the subplots. If you want to change the labels, you have functions on title, x label, and y label, and you can do all of that. Okay. And changing the x limits, you have this. There's a function called plt.axis, and you can specify equal, and that's going to make set the aspect ratio to be equal, so that if you plot, say, a circle, it will look like a circle in the thing. Whereas if you don't set the axis to have the same aspect ratio, circles will look like either stretched out or flattened, right? So aspect ratio preserves that, and this is what we have here. Okay, there's all sorts of plot options, right? And there's a variety of colors, so you can look up matplotlib named colors, right? And so you can click this. You can click the documentation as far as the list of named colors go. All right. So the basic colors are blue, green, red, cyan, magenta, yellow, and black. Okay. And you can kind of, and you can use any of these names. And so they have things like Indian red, light coral, rosy brown, brown fire brick. I don't know. Thistle. All right, close your eyes and guess what color. Guess what color burleywood is. What do you think? Okay, it's this color right here. It's clearly burleywood, all right? All right. I don't know. Okay, again, close your eyes. Think of what color you get when I say cadet blue. Here's some kind of blue, right? Okay, it's this color, all right? Cadet blue. All right, well, anyway, so you have a bunch of names. These are names for, it says CSS. Is that really true? I'm going to type in cadet blue. See, I don't know if there's an agreement on what color this is. This doesn't look like one color. Okay, well, and it looks different on my screen than on the projector, so. Well, anyway, so here I did maroon and dark slate gray. You can also change the markers, okay? D, I think, does diamonds, and H, capital H, does hexagons. And so that's what I have. In maroon, I have diamonds, and these are little hexagons. And again, you can also do matplotlib plot shapes or markers, right? Okay, and so you have, these are the different shapes you can plot. So I think by default it's the point, but you can give it, you can say I want, and the way you specify these things are a little bit funny, but you can do points and circles. If you do a dot, you get the point. If you do an O, you get a circle. A V will give you a down triangle, and a Shift 6, the caret, will give you an up triangle. Less than or right than will give you triangle left, triangle right, and then you've got all of these other things. The octagon, the square, the pentagon, star, okay. Just different options. Let me see. Matplot. Let's see, marker size. Okay. So if you wanted to do scatter and you wanted to change the marker size is just S. Okay. So let's just try that. I'll do S equals 3. I guess that's small. Let's try S equals 30. 300? Oh. Okay. I guess that's size 300 for the diamonds. S equals 200. These are hexagons and diamonds. Okay. Well, anyway, you can play around with that. Two-dimensional functions. Here, I can create something called a mesh grid. All right. This is not. So here I've got 0, 1, and 2, and then and y is -1, 0, 1, 2, and what it's going to do when you say mesh grid xy, it takes the x, so it's trying to align, and says x and y have to will have to be a 4x3 matrix, okay, or 4x3 array, and so it duplicates the 0, 1, 2 4 times like this, and it duplicates -1, 0, 1, 2 like this, okay? So what mesh grid does is it will return back two arrays, two-dimensional arrays, an x and a y. The x will go 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and the y will go -1, 0, 1, 2, -1, 0, 1, 2 in columns that way. Does that kind of make sense what it's doing? X was 0, 1, 2, and it gets duplicated, so it's a 4 by 3. Y is negative 1, 0, 1, 2, and it gets duplicated, so it's also 4 by 3, but it's duplicated the other way. All right, and here I'm going to define a function that takes in x and y and returns its product. And I'm going to apply that to the mesh grid. So we've created our mesh grid, and I'm going to apply this function to our mesh grid and print out the result z. So this is what I have, okay? So if I do negative 1 times this column of zeros, this column ends up being 0, right? This column I'm multiplying by 1, and I get that. And then this last column, negative 2, 0, 2, 4, I'm taking this column and I'm multiplying everything by 2 to get this last column. Does that make sense, what I'm doing here with this xy? Okay, so here, what I'm going to do, I'm taking values from negative 3 to 3, linear space 101, y is also negative 3 to 3, 101, and I'm going to create a mesh grid. All right. Okay, and then what am I doing here? G is a function of x and y, and I'm returning e to the negative x squared times e to the negative y squared. Does that look familiar? What does that sound like? We're missing some constants, but it's the product of two like normal PDFs, right? So e to the negative x squared is going to be proportional to a normal PDF. E to the negative y squared is also proportional to a normal PDF. And so I've got two independent normal PDFs multiplied together. And that's going to give us z, okay? And if we plot out z, it's going to be 101 by 101. All right. And so there's a few things. We can run contour. What will contour produce? So I've got two independent normal distributions. So I've got a joint distribution of two independent normals. What does that look like? Circles, right? We've got a hill, and we're drawing contour plots, okay? So there you go. You've got circles here, and then, so that's what we have, the contour. There's image show, which just kind of colors it in like this, and this is kind of what we have. We don't have like a 3D plot thing here, but you have that, okay? I'm going to go ahead and just open up the one that I've got going for Fridays, and we'll do even more. Okay. So here are some more things. We're going to import NumPy, pandas, matplotlib, same as usual. You can just specify the colors of the lines, okay? You just keep calling plot over and over and over. You can specify colors blue, green, and red. Okay, these are kind of your standard colors which we saw. And you can also specify line style. The line style, you use kind of this shorthand notation. Solid line, dash line is dash dash, dash dot, and dotted using the colon, okay? And by default, I didn't specify different colors for these, but by default, it does different colors, okay? And if we can zoom in and see kind of the different things. The solid dash, this is the dash dot line and the dot dot line, right? So if you're printing in black and white and you don't have the luxury of colors, you can specify different line styles using like this, okay? And again, you can always look up the different line style references. I think this is all we've got. Here are just some random numbers. Okay, random uniform. here's a probability question. If I divide this up into a grid of squares, and we count how many dots are in each square, what is the distribution of dots? Or the distribution of the count of dots in a square. So here I just did random uniform numbers, okay, from 0 to 1. But let's say I make a grid of 25 squares here, okay? So I've got this square, and they're all not going to have the same amount of dots in them. What distribution will it follow? So count of a random uniform thing within a certain interval or certain spot is what? Poisson distributed, right? So how many customers walk through the door in a set amount of time is going to follow Poisson distribution. How many dots fall in a designated area of space, if the dots are randomly uniformly distributed, will also be Poisson, okay? So anyway, this is what we call a Poisson point process. So anyway, this is what we have. We can do all sorts of stuff. I'm going to use Z to specify size and W to specify color, okay? So Z is going to be a vector of 100 values of random numbers between, I guess, 1 and 1,000. Okay, 100 times a random integer between 0 and 10. And then W is going to be a vector of random numbers 0 through 5, okay? Or 0 through 4, I should say. So I've got 0, 100, up to 900 here for Z. And W is, 2014, just some random integers from 0 to thing, okay? And here, I'm going to take my array of colors, red, blue, green, magenta, yellow, and I'm going to subset the colors using square bracket notation using this vector W, okay? So it will go green, red, blue, 4 is yellow, and so on and so forth. So if I print out C, I'm going to get green, red, blue, yellow, right? So can we see what's happening here? As when I subset the colors, square bracket on the W, okay? And so here what I can do is I can produce a scatter plot where X and Y are mapped to X and Y. The size is mapped to this vector Z, and the colors are mapped to this vector of colors, okay? So I can plot this with basically more information, right? So we can take the X and Y thing, but we can also modify the color of the dot and modify the size of the dot based on a third and fourth variable. So you can do that. And in order to do that, you have to kind of create vectors that will correspond to the size and a vector corresponding to the color. It's a lot more work manually, whereas in R and ggplot, you could have used ggplot and the AES specification to map certain variables to certain visual aspects, okay? This is all we can do. We can use alpha to specify the transparency, and here is what our plot ends up looking like, okay? Unfortunately, not all of the things can be mapped, and I forgot which ones. So you can't map the markers to a variable, so we can't, like, I can say marker I want stars, and suddenly it looks like we're having a party. But you can't say I want stars for this variable and I want dots for circles for this variable, unfortunately. Okay. Okay, and then I think we already saw this, all of these different shapes here. All right, so here I'm going to create a call figure. Okay, matplotlib figure will generate a figure, and you can specify some attributes, like I want it to be a 5 by 5 size figure. Okay, And here I call scatter twice, okay? So the first time, I'm going to plot certain values where the size of the thing is 100. I've got red marker, and I'm going to give it a label, okay? Label is group A. I call scatterplot again on some different values, and I change the marker to the circles, and I give it a label group B. When I then call legend will put this thing up in the corner with the appropriate labels. Okay. If I didn't call legend, okay, it would produce this, but then I can call legend, and it will add the legend based on the labels I provide. Okay. If I didn't provide labels, okay, so I didn't provide a label for this, for the blue dots, so it doesn't show up in the legend. Okay, so the legend, you know, you've got to kind of give it some internal information. So the label information won't show up anywhere unless you call legend, and legend is only able to print something if you provide legend label information as well. All right, here is a subplot thing, okay? And so I'm going to make a 9x6 image, all right? And so for I in range 1 through 7, so that's going to go from the numbers 1 through 6. And I'm going to say we're going to make a subplot, 2 rows, 3 columns, and we're going to start off at subplot I, okay? So first it's going to start off in subplot 1. Then it's going to go to subplot 2, then subplot 3, and we can see how each of these things are going to be. In each subplot, all I'm going to do is add the text at the location 0.5, 0.5, and the text is going to be plot and the string 2, 3i, okay? So what is this going to look? It's just going to be a plot of grids, okay? Whoops. Where in each thing it has the text, where it says this is plot 2, 3, 1, okay? Subplot 2, there's 2 rows, 3 columns, and this is subplot 1. 2 rows, 3 columns, subplot 2, 2 rows, 3 columns, subplot 3, 4, 5, and 6, okay? And of course, probably in each of these, you would normally add some points or data to do, okay? If, this is like too much work, in my opinion, but this capability does exist, okay? So here, I'm going to do something called a grid specification. And again, I don't even know if I should have included this, but here it is, all right? Because it's like so much of a pain, like who's gonna wanna do this, right? Okay, so grid specification, we're gonna go 2 rows, 3 columns. Here's kind of our W space and H space, right? So how we're gonna space things apart, all right? And then, this is the worst. Grid spec uses 0-based indexing unlike subplot, which uses 1-based indexing, so it's all a mess, right? So 0, 0 is gonna be the top left corner, right? So you've got 2 rows, 3 columns. Grid 0, 0 is going to be our top left, and I'm going to just do a scatter plot, okay, between X and Y. And then, and this, the next thing I'm going to call subplot, and here I'm saying I want grid row 0, so that's the top row, and then over here, columns 1 through 3, okay? So in my grid spec, I said 2, 3, right? So that's 2 rows, 3 columns. So basically 1, 3, when I slice it that way, will give me basically the top right, okay? Let me just kind of show you what happens here. So here's grid 0, 0. This is grid 0, row 0, top row, and then 1, 3 gives me this one and this one, okay? And so it draws the plot across these two. All right, then I call histogram, so it plots a histogram. Over here, I call subplot. I want row 1, okay, row index 1. And as far as the columns go, I want 0 through 2, which will give me this. And then lastly, I'm going to plot grid 1, 2, and it does this. And I'm just plotting some numbers here, okay? So you can kind of, it's like drawing a table, and then you can shade in like multiple of these cells together and draw a plot across several of these cells, and you can specify it all using subplot and grid spec, okay? But again, it's kind of a pain. Who wants to do that, right? All right, I'm not even going to get into this. All I did was copy and paste someone else's code, okay, as far as this thing goes. But if you use grid spec, you can create, I guess, fancier plots, all right? So what it's doing is it's going to generate some multivariate normal values, okay? And using grid spec, it's going to plot a histogram for the x, a histogram for the y, okay? And then basically the scatter plot in the middle. All right, so using grid spec, what it did was it says it's going to go a 4x4 grid, okay? And then the x histogram is going to go on the bottom row, and I'm sorry, the x histogram goes on the bottom row with starting at index 1 through the rest. So 1, 2, 3, it draws the x histogram there. The y histogram starts at the kind of the first column 0, and goes all the way up to the second to the last row. Okay, so that's what it's saying, right? And then everything else here, we got the big kind of grid here. All right, who wants to do this, right? This is such a pain, but you can do it. Okay, the functionality exists. It's kind of like in R. Do you ever use par mf row? Okay, it's not fun, right? But it exists. Okay, it's kind of like that. Okay. All right. More histograms. All right, here we go. There's a few other things. So like when you do a histogram, plot.histogram, bins, okay? Get used to this, because R you use breaks, and here you're using bins, okay? You can specify the transparency, you can specify color and edge color. Edge color is kind of the lines. So by default, there's no edge color. Okay, but if you want to try to emphasize that you've got all these different bars, you can do that. Okay, and then there's a step-filled color histogram, such as this, and it looks like it draws the outline, but not the lines in between. Okay, so step-filled draws kind of like, I don't know, that. That's what you get. Oh, here we get to use quargs. Do you guys remember quargs? Keyword arguments. So it's kind of like the ... in that. So here I'm going to generate 3 normal distributions with mean 0, standard deviation 0.8, mean -2, standard deviation 1, mean 3, standard deviation 2. Okay, and for all of them, I am providing a dictionary of kind of these arguments. All of them we're going to have histogram, hist type step-filled, alpha to be 0.3, density to be true, bins to be 40, edge color to be black. And rather than having to copy and paste these arguments every single time I call plot histogram, I can do plot.plt.histogram and give it the quargs. Okay, I can do ** quargs, and it's going to take the dictionary and fill it in. Right? And so that way, later on, if I wanted to change one of these settings, I don't have to copy and paste that line every single time. right? So if I wanted it from density true to be density false, which will change this part from the density portion to be kind of a count, okay? I can do that, and it's going to change it for all three, right? I can turn that to true. I can change this to be bins 20 for all of them, and I don't have to go through this process of copy paste, copy paste, copy paste every single time. Okay. You know, I can change this to be, what was that color that we were looking at? Matplotlib named colors. Okay, something happened here. I don't want this. I just want the names. Okay. I'm sure there was some funny named color. Apple. Is that going to be a color? No. Apple green? No. Purple. Okay. Purple works. Okay, so anyway, you have that. 2D histograms, you can do that. You can do hist 2D. All right, so here's the multivariate normal, mean zero, covariance matrix, and you get this, all right? Two-dimensional histogram. There's another two-dimensional histogram called a hex bin. It draws hexagons. I don't know if you can even see this. It's like tiny. Okay. You get hexagons instead of rectangles. Pretty much the same. All right, we'll leave Seaborn for another day. I guess Friday. All right, we'll stop there, and yeah, we'll do some more exploration here. Practice those projects.